Hello, let's solve practice set 2.1. Question first. Identify with reason which of the following are Pythagorean triplets. We know that Pythagorean triplet is a triplet in which square of the largest number equals sum of the squares of remaining two numbers. Then that triplet is called as Pythagorean triplet. Okay. Now let's verify whether given triplets are Pythagorean or not. Practice at 2.1. Question first, sub question first, solution. Here given triplet is 3, 5, 4. Okay. Among 3, 5, 4, 5 is the greatest number or largest number. That's why let's consider here square of largest number is equals 5 square and square of 5 is 25. Let's call it as equation first. After that, sum of squares of remaining two numbers is equals. Remaining two numbers are 3 and 4. That's why 3 square plus 4 square. Square of 3 is 9, square of 4 is 16, and their addition is 25. Let's call it as equation second. And therefore, from 1 and 2, square of largest number is 25. Sum of the squares of remaining two numbers is also 25. Means 5 square equals 3 square plus 4 square. That is square of largest number is equals sum of squares of remaining two numbers, and therefore by converse of Pythagoras theorem, by converse of Pythagoras theorem, 3, 5, 4 3, 5, 4 is Pythagorean triplet. Pythagorean triplet. Okay. Similarly, we can solve the rest of the sums. Number 2, solution. Here given triplet is 4, 9, 12. Okay, therefore here square of largest number equals 12 square, and square of 12 is 144. Square of 12 is 144. Let's call it as equation 1. Now sum of squares of remaining two numbers is equals. Remaining two numbers are 4 and 9. That's why 4 square plus 9 square. Square of 4 is 16 and square of 9 is 81. And sum of 16 and 81, let's add them. 6 plus 1 gives us 7 and 1 plus 8 gives us 9. Means that sum is 97. Let us call it as equation second. And therefore, from 1 and 2, yes, 12 square is not equals 4 square plus 9 square, because 12 square is 144 and sum of the squares of 4 and 9 is 97. That is square of largest number is not equal to sum of squares of remaining two numbers. Okay, and therefore given triplet 4, 9, 12. 4, 9, 12 is not Pythagorean triplet. Let's see third triplet. 5, 12, 13. Question third, solution. Here square of largest number equals 13 square. Okay, and square of 13 is 169. Sum of squares of remaining two numbers are 5 and 12. That's why sum of squares of remaining two numbers equals 5 square plus 12 square. Square of 5 is 25 and that of 12 is 144. 144 plus 25 gives us 169, and therefore from 1 and 2 square of largest number is equals sum of the squares of remaining two numbers. Okay, because here you may note what's that, 13 square equals 5 square plus 12 square. That is square of largest number equals sum of the squares of remaining two numbers. And therefore given triplet which is 5, 12, 13. Therefore 5, 12, 13 is Pythagorean triplet. Okay. By converse of Pythagoras theorem. By converse of Pythagoras theorem. Okay. We can apply converse of Pythagoras theorem. We can apply converse of Pythagoras theorem if and only if square of one number is equal sum of the squares of remaining two numbers. Then and then only we can apply converse of Pythagoras theorem. Otherwise we cannot. Number 4, solution. Here given triplet is 24, 70, 74. Therefore here square of the largest number equals 74 square. Let's obtain square of 74. 74 into 74. 4 4s are 16, carries 1. 4 7s are 28 and 1, 29. 7 4s are 28, carries 2. 7 7s are 49. 49 and 2, 49 and 2, 51. Okay, and their addition 6 plus 0, 6, 9 plus 8, 17, carries 1, 2 plus 1, 3 and 1, 4, 5, 4, 7, 6. Okay, square of 74, 5, 4, 7, 6. Sum of squares of remaining two numbers. Remaining two numbers are 24 and 70. Means 24 square plus 70 square. Square of 24 is 5, 7, 6. And square of 70, 4900. 4900. 0 plus 6 gives us 6. And then 7 plus 0 gives us 7. And then 9 plus 5 gives us 4. And carry 4 and 1, 5. Again that sum is 4, 5, 4, 7, 6. And therefore from 1 and 2. What's from 1 and 2? 74 square is equals 24 square plus 70 square. That is, square of largest number is equals sum of squares of remaining two numbers, and therefore given triplet in a given sequence 24, 70, 74. 24, 70, 74 is a Pythagorean triplet by converse of Pythagoras theorem. Remember that we may consider that triplet in any sequence, either in ascending or in descending or in random order. We may consider that triplet. Number 5. Given triplet is 10, 24, 27. Question 5th. Solution. Here square of the largest number is 27. 27 square. Let's derive square of 27. 27 into 27. 7 7s are 49, carries 4. 7 2s are 14. 14 and 4, 18. Okay. 2 7s are 14, carries 1, 2 2s are 4 and 1, 5. Let's add these numbers. 9 plus 0 gives us 9. 8 plus 4 gives us 12, carries again 1. 1 plus 5 is 6. 6 and 1, 7. Means that sum is 729. Square of 27 is 729. Let's call it as equation first. Sum of squares of remaining two numbers. Remaining two numbers are 10 and 24. That's why 10 square plus 24 square. Square of 10 is 100 plus square of 24, 576. 576. And let's find what is their addition. 6 plus 0 gives us 6. 7 plus 0 gives us 7. And 1 plus 5 gives us 6. Okay. That addition is 676. And square of 27 is 729. And therefore from 1 and 2, 27 square is not equal to 10 square plus 24 square. That is, square of largest number is not equal to sum of squares of remaining two numbers. And therefore given triplet 10, 24, 10, 24, 27 is not Pythagorean triplet. Either you may say by converse of Pythagoras theorem, or without saying that you may declare it is not Pythagorean triplet. Let's see number 6. 11, 60, 61. Question 6th. Solution. Here square of the largest number equals 61 square. Let's obtain square of 61. 61 into 61. 1 1s are 1, 1 6 are 6. Again 6 1s are 6, 6 6 are 36. Okay, let's add these numbers. 1 plus 0 gives us 1. 6 plus 6 gives us 12. Carries 1. 6 and 1, 7. 3 7 2 4. Let's write here square of 61. 3 7 2 1. Sum of the squares of remaining two numbers, and remaining two numbers are 11 and 60. That's why let's mention here 11 square plus 60 square. Square of 11 is 121 and square of 60 3600. Now 1 plus 0 gives us 1, 2 plus 0 gives us 2, and 1 plus 6 gives us 7, and 0 plus 3 gives us 3. 3721. Square of the largest number 3721, and sum of the squares of remaining two numbers is again 3721, and therefore from 1 and 2 we may write there 61 square equals 11 square plus 60 square. That is, square of largest number is equals sum of squares of remaining two numbers, and therefore given triplet that is 11, 60 and 61. Therefore 11, 60, 61 is a Pythagorean triplet by converse of Pythagoras theorem. Let's see question second. In figure, angle MNP equals 90 degree. Seg MQ perpendicular seg MP. MQ equals 9. QP equals 4. Find NQ. Okay. If you observe a diagram carefully, you may note it is a right angle triangle. Okay. And we know that in a right angle triangle, perpendicular drawn through the vertex of right angle on hypotenuse is the geometric mean of the segments into which that hypotenuse is divided. Okay, and that is called as theorem of geometric mean or geometric mean theorem. We are going to apply that theorem here. Here, in a triangle MNP, angle MNP equals 90 degree. Seg NQ is perpendicular to hypo MP such that M dash Q dash P, and therefore directly we may write there NQ square equals MQ into QP by theorem of geometric mean. By theorem of geometric mean. Now just put known values. Therefore we don't know about that NQ, that's why NQ square will be as it is. But MQ is 9 and QP is 4. 9 4s are 36, and therefore NQ square equals 36, and therefore NQ equals 6 by taking square roots. NQ equals 6. Question third. In figure, angle QPR equals 90 degrees. Sec PM perpendicular sec QR and Q dash M dash R. Seg PM perpendicular QR. PM equals 10. QM equals 8. Find QR. Okay. Now if you observe a diagram carefully, you may know triangle QPR is a right angle triangle right at vertex P. Okay. In which seg PM is perpendicular to hypotenuse QR, and that perpendicular is through the vertex of right angle, and we know that such a perpendicular is geometric mean of the segments into which hypotenuse is divided by it. Okay. Same thing we are going to apply here. Question third, solution. Here, in a triangle PQR, angle QPR equals 90 degree. Which angle? Angle QPR equals 90 degree. Seg PM is perpendicular to hypotenuse QR such that Q dash M dash R, and therefore PM square equals QM into MR by theorem of geometric mean. By theorem of geometric mean, and therefore 10 square equals 8 into MR. Okay. 10 square is 100. Okay. 100 equals 8 into MR, and therefore MR equals 100 upon 8. 8 ones are 8, 8 ones are 8. Remainder will be 2. By taking 0, it will form 20. 8 2s are 16. Remainder will be 4. No digit to take, that's why we will put decimal and take 0, then it will form 40. 8 5s are 40. And therefore, MR equals 12.5. Now, we are interested with QR. Now, QR equals QM plus MR. Since Q dash M dash R, that equals Q is 8. That 8 we can write 8.0 plus MR is 12.5. Let's put here. Now 0 plus 5 gives us 5, decimal below decimal. 8 plus 2 gives us 10, carries 1, and 1 plus 1 is 2. And therefore, QR equals 20.5. Question 4. See figure. Find RP and PS using the information given in triangle PSR. If you observe triangle PSR, you may note one of the angle have measured 90 degree because symbolically he represented it as a right angle. Second angle have measured 30 degree. 90 plus 30 gives us 120. And we know that angle sum property of a triangle, sum of the measures of angles of triangle is 180 degree. 180 minus 120 gives us 60 degree. Means third angle must have measured 60 degree. Means it is 30, 60, 90 triangle. And we can apply theorem of 30, 60, 90 to this triangle to find PR as well as PS. Because SR, which is the side opposite to 30 degree. And we know that side opposite to 30 degree is half of the hypotenuse. Okay, let's apply here. In a triangle PSR, angle PSR equals 90 degree, angle SPR equals 30 degree. Since this is V1, okay, and therefore third angle, which is angle PRS, must have measured 60 degree. Since remaining angle of triangle, and therefore triangle PSR is 30, 60, 90 triangle. Okay, to call it as 30, 60, 90 triangle, but to write it as 30 degree dash, 60 degree dash, 90 degree triangle. Okay, and therefore side opposite to 30 degree means which is that SR is half of hypotenuse. Hypotenuse is PR. Since side opposite to 30 degree. Okay, and therefore SR which is given as 6 equals half of PR, and therefore PR equals 6 into 2, and therefore PR equals 12. Okay, now we have PR 12, angle PRS 60 degree. Let's underline these things because these were not given. We calculated them. Now PS equals root 3 upon 2 into PR. That is, since side opposite to 60 degree, we know that if the angles of triangle are 30, 60, 90 degree, then side opposite to 30 degrees half of the hypotenuse, and side opposite to 60 degrees root 3 by 2 times the hypotenuse. Okay, That's why we wrote it as PS equals root 3 by 2 into PR equals root 3 by 2 into PR is 12. 2 ones are 2, 2 6 are 12, and therefore PS equals 6 root 3. Equation second. Question 5th solution. For finding AB and BC with the help of information given in figure 2.20, complete following activity. AB equals BC. If you observe a diagram carefully, it is given in a diagram. That's why we are going to say there, since it is given. Therefore, angle BAC equals. Now here you may note, angle ABC have measured 90 degree. AB equals BC means it is isosceles right angle triangle, and we know that in the isosceles right angle triangle both of acute angles have measured 45 degree. That's why angle BAC must have measured 45 degree, and by 45, 45, 90 each of right sides are 1 upon root 2 times of the hypotenuse, means therefore AB equals BC equals 1 upon root 2 into AC equals 1 upon root 2 into length of AC is given as root 8, and root 8 is nothing but root of 4 into 2. Root of 4 into 2. Root of 4 is 2, and 2 is not again perpetual. That's why second 2 will be as it is in a root. That's why root 8 is 2 root 2. That's why next step will be 1 upon root 2 into 2 root 2. Root 2 ones are root 2, root 2 ones are root 2. 1 into 2 into 1 gives us 2. And therefore, AB equals BC equals 2. Okay. AB equals BC equals 2.